Welcome to the chapter Average. Here we are going to see about average definition, mathematical expression, example, consecutive numbers, logic behind average, and equal distribution method. First we'll see what is meant by average. Average is defined as sum of observation to that of the total number of observation. The mathematical expression can be given by average equal to sum of observation divided by total number of observation. Consider the example of aggregated marks in few subjects. Let the subjects be English, Tamil, Maths, Science and Social, and the marks obtained by each subject out of 50 is given as 45, 42, 43, 40 and 30. Now we are going to calculate average using this mathematical expression. This can be done by sum of observations divided by total number of observations will yield you the averages 40. Next we are going to see about consecutive numbers. Why we are going for consecutive numbers is average mostly falls under consecutive number. In the above example, we consider only 5 subjects. In that case, going with the mathematical expression is very easy and very eco-friendly also. But if you are consider you are having 500 terms or 1000 terms, is it possible to calculate average using the mathematical expression for those 500 terms and for those 1000 terms? It is not possible at all. You couldn't able to complete it within a fraction of second. So we are going for consecutive number. What are the numbers we call it as a consecutive number means? The number which comes next to each other and the difference between the number is same. I have given you an example for consecutive numbers and non-consecutive numbers. Consider the first set of numbers 1, 3, 5, 7, 9. From this we can say that the numbers are next to each other and the difference between the number is 2, that is same number. So this comes under consecutive number. Now consider the second set of numbers 1, 3, 4, 7, 8. From this we can say that the number is next to each other but the difference between the number is not same. So in that case, this is not a consecutive number. We know the average mathematical expression is sum of observation divided by total number of observation. This is applicable only for lesser number of terms. If you have larger number of terms, that cannot be applicable because it takes lot of time. So we are going for the logic behind average. So what is the actual logic happening behind average is equal distribution. I will explain what is equal distribution using this example. 1, 2, 3, 4, 5. So we are going to use the normal method of mathematical expression. So we can get the averages 3 here. So what does actually mean this? 1, 2, 3, 4, 5 will yield you the average is 3, which means the average gets equally distributed to all the given terms. That is nothing but 1 becoming 3, 2 becoming 3, 3 becoming 3, 4 becoming 3 and 5 becoming 3. Thus the average becomes 3. This is the normal method to calculate the average using mathematical expression. So, if we have 500 terms or 700 terms or 1000 terms, this cannot be applicable. So, we are going for a shortcut method. This shortcut is applicable only if a number is a consecutive number. I have already told you consecutive number is nothing but the number next to each other and the difference should be the same. In this case, if the number of terms is even, then the average of the middle number will give you the average for the given number of terms. If the number of terms is odd, then the middle number will be the average for the given number of terms. Consider an example 2, 4, 6, 8. Since we have 4 terms here, 4 is an even term. So take the middle terms 4 and 6. Find the average for 4 and 6 will yield you the average for 2, 4, 6, 8. Thus the average is 5. Consider the second example. 1, 2, 3, 4, 5. Since we have 5 terms, 5 is an odd term, then the middle term will be the third term. The third term is 3 here. So the average is 3. As simple as that. I have told you the logic behind average is equal distribution, right? So equal distribution is applicable in all the cases, means it is not. In different cases, it holds different methods. Now I am going to share 3 major cases that falls under equal distribution. The first case is if a number is increased or decreased by some number, then the average will also be increased or decreased by the same number. Consider the example 1, 2, 3, 4, 5 will give you the average is 3. If I am going to increase the number 1 by 1, that is I am going to make the number 1 as 2, then we need to go with equal distribution. So equal distribution means I am distributing that 1 to all the given terms. So if all the given terms is increased by 1, then the average will also increased by 1. So we no need to waste our time by calculating 3 plus 4 plus 5 plus 6 plus 7. Instead, we can directly do the calculation in the average part itself. If consider an example, you are having 500 terms. Let the average of 500 terms be 75. If I am going to increase a term among the 500 term by 5, then what will be the average? You can directly say 75 plus 5 will give you 80. Thus, the average for the 500 terms is 80 here. The second case is if a number is added or removed which is equal to the average, then the average will remain the same. Consider 1, 2, 3, 4, 5 will give you the average is 3. Now I am going to add a number 3 to the given 5 terms. So what will happen? 1 plus 2 plus 3 plus 4 plus 5 plus 3 will give you the average is 3 again. So from this case 2, we can conclude that if we add or remove a number which is equal to the average, then the average will remain the same. Consider the previous example I have told you. For 500 numbers is there, let the average of 500 number be 75. If I am going to remove or add a number 75 out of that 500 number, so the average will be 75 only, because I am adding the number which is equal to the average. So the average will remain the same. We no need to calculate. Again, we no need to go with the formulas. Case 3. If a number is added or removed which is not equal to the average, then the difference in the average will be equally distributed to the given number. Consider 2, 4, 6 will give you the average as 4. Now I am going to add a number 8 which is not equal to the average. So 2, 4, 6, 8 will give you the average as 5. So the difference between the average means 4 and 5. The difference is 1. I am going to distribute this 1 to the given terms. So, thus 2 becoming 1, 3, 4 becoming 5 and 6 becoming 7 will give you the average as 5. So these are the 3 cases that major falls under equal distribution method. Why we are going for this equal distribution method is, you can, if they have given you lot of terms like 500 terms or 1000 terms or 5000 terms, it is not possible to calculate for all the 5000 terms using the mathematical expressions. In such cases, we are going with equal distribution method. Though we know the formulas, if we do any mistake in a formula, like instead of plus, if you have used subtraction instead of subtraction, if you have used plus, means the total formula will go wrong, thus the sum will also go wrong. So don't need to follow the, just know what is the mathematical expressions for each and every term, but try to go with the logic. The logic helps you to solve the problems within a fraction of a second rather than using formulas.